Hello, welcome to the Data Structure and Algorithms online tutorial video. In this video, we will learn about an interesting data structure. It has got various number of application in computer science, and that data structure is tree. So far in this series, we have learned about linear data structure, arrays, linked list, stack, and queue. All of these are basically collection of different kinds of data which are arranged in a sequential manner. In all of the data structures shown here are having a logical start and end. Now we know that these data structures are ways to store the data in computers. For different kind of data, we use different data structure. Choosing data structure depends on many factors like what need to be stored. Some data structures can be best fit for some kind of data. Cost of operations. To minimize the cost for the operations for the most frequently performed operations, suppose if we have a simple list in which we have to perform search operation, then we can create an array in which elements are stored in a sorted order to perform the binary search. The binary search works very fast for this simple list as it divides the search space into half. Memory usage. Sometimes we want to make less memory usage. Now let's understand what is tree in detail. Tree is a data structure that is often used to represent hierarchical data. For example, if we want to show employees of organization with their positions in organizational hierarchy, then it can be shown like this. Let's say this is an organizational hierarchy of some company, and in this company Rachana is the CEO and has two direct reports, John and Tina. Then John has three direct reports, Rahul, Savita and Gunjan. John is manager of these three, and Tina also have two direct reports, Raghavi and Shankar. Tina is the team lead of these two, and Raghavi has one direct report, Sneha. This particular structure you are seeing here is tree. Well, we will see the structure upside down to understand the tree structure with the resemblance of tree. The root is at the top and we are branching out in a downward direction. Logical representation of the tree will be like this, root at the top and branching downwards. Let's first understand the logical definition of tree. Tree data structure can be defined as a collection of entities called nodes linked together to simulate hierarchy. It is a non-linear data structure because it does not store in a sequential manner. It is a hierarchical structure as elements in a tree are arranged in a multiple levels. The topmost node is known as root node. Each node contains some data and data can be of any type. In the tree structure shown here, the node contains the name of the employee, so the type of the data would be string. Each node contains some data and the link or reference of the other nodes that can be called as children. Now we will see some of the basic terms that we will use to understand tree data structure. Here is the logical representation of tree. As I said, each node will be having some data. I am going to number these nodes in the tree so that I can refer these nodes using numbers. I am using integer data type to refer these nodes of the tree. The root node is the topmost node in the tree hierarchy. Root node doesn't have any parent. In the structure shown here, node number 1 is the root node of the tree. If a node is directly linked to some other node, it would be called as a parent-child relationship. If the node is descendant of any node, then the node is known as the child node. If the node contains any subnode, then that node is said to be the parent node of that subnode. The nodes that have same parents are known as siblings. The node of the tree which doesn't have any child node is called as a leaf node. A leaf node is the bottommost node of the tree. There can be any number of leaf nodes present in a general tree. Leaf nodes can also be called as external nodes. A node has at least one child node known as internal. Ancestor of a node is any predecessor node on a path from the root to that node. The root node doesn't have any ancestors. In the tree shown here, node 1, 2 and 5 are the ancestor of node 10. The immediate successor of a given node is known as descendant of a node. In the tree, the node 10 is the descendant of 5. Watch next video for further topics of tree. Please subscribe to our channel if you haven't subscribed yet. Do not forget to hit on bell icon to get notified whenever I post new video. For further notes and programming examples, please install DSA application from Google Play Store or from the link given in the description below. Let us know if you have any query in the comment section below. Thank you for watching.